Okay, so we're going to look at the bottom of your examples, and we're going to do some of the inequalities. So let's start with number 6. And solving the inequalities is very similar. The only difference really is that you're going to get a range of values for your answer and not just one number. So much of the process is the same. I still need to find my LCM or common denominator. So for this one, what would the LCM be? 8a, right. Or you could think of it as 2 cubed times a. You're going to need 3 factors of 2 and 1 factor of a. Okay, so I'm going to multiply everything all the way through by 8a to get rid of the denominators. And the other thing I'm going to change here is, instead of leaving that inequality symbol, I'm going to solve the related equation. I'm going to make it an equal sign just so it's easier to look at and work with. And then in the end, I'm going to reuse this inequality to help me find my final answer. So when I multiply this first fraction, the 4a is going to reduce with the 8a. So I'll just have 2. This second fraction, the 8a's are going to completely reduce out. So that's just going to be 5. I'm going to make it equals instead of an inequality. So my last fraction is going to reduce with the 8a to 4a. Okay, so I'm just going to solve for a. So I have 7 equals 4a. 7 over 4 is a. Okay, so this value that I just found is called a critical point. Now you usually have 2 critical points. One from the solution of the problem, and then one from the LCM when I set the LCM equal to 0. Any factor of the LCM that has a variable, you need to set equal to 0 and solve. Okay, so this is my second critical point right here. So what that does is, on the number line, it's going to break up that number line into 3 parts, and I need to pick values from each part, substitute those values into the original inequality, and see which regions make it true. You could have more than 3 regions. Sometimes you'll have more than 2 critical points, but this one just has 2. So something less than 0, I'm going to use a equals -1. I like to use the easier ones, okay, and just make it simple to substitute in. This middle region, I'm going to use 1. That's between 0 and 7 over 4. And then the last region, I'm going to use a equals 2. Okay, so I'm going to take my value for a and plug it into the original inequality, see if it makes a true statement. So I'm going to have negative 1 over 4 plus 5 over -8 greater than 1 over 2. And you can type those fractions into your calculator to help you simplify it faster so you don't waste a lot or use a lot of time with this part. So that's going to work out to be -7 over 8 is greater than 1/2, which that's not true. Okay, so that part doesn't work. So I'm going to test this middle region, going to take that value for a, plug it into the original inequality. So I have 1 over 4 plus 5 over 8 is greater than 1/2. So 7 over 8 is greater than 1/2. That's true. Okay, it's almost, 7 over 8 is almost 1, so that's bigger than 1/2. And then the last one, where a is 2, 1 over 8 plus 5 over 16 is greater than 1/2. So that'll work out to be 7 over 16 is greater than 1/2, which that's not true. It's not quite a half. So that one's not going to work. It's just this middle area, and you are not going to include those values because the original inequality is only greater than, it's not equal to. So you're not going to include the values. Okay, and this is an AND solution. So you're going to write it as a AND inequality. 0 is less than, a is less than 7 over 4. And that's going to be your solution. Okay, any questions? I'd like you to try one on your own. Okay, so let's try number 7. I'll do it up here, and we'll see how you do.